Ja, hallo, die Pause ist vorbei. Wir begrüßen euch zurück hier im Cloud-Track von der Navigate. Wir hoffen, ihr habt alle einmal Getränke aufgefüllt und einmal die Blase entleert und seid jetzt bereit für den nächsten Input. Ich darf unseren nächsten internationalen Gast vorstellen und deswegen switche ich jetzt auch direkt mal auf Englisch. So, our next speaker is going to join us from the west coast of the USA, actually. She's a database and AI expert working at Redgate. And as one of only 6 women of the Oak Table, which is Oracle Scientific Network, she brings a lot of in-depth database knowledge. So therefore, she should be able to address many common challenges when migrating databases into cloud, which is always kind of struggle or
for sure, yeah,
a challenge.
Yeah.
So yeah, welcome, Kellyn.
Hello.
Welcome, Kellyn.
No problem.
I hope you could recharge your batteries a bit from your last trip to London.
Did a little bit. I sound like Greta Garbo right now. The voice is a little low, but other than that, I'm good.
Okay, sound great. So stage is yours. Feel free to inspire us.
Thank you so much. Thank you for the wonderful introduction, and it's so nice to see everyone here. I'm going to skip over my introduction. I think we kind of already introduced myself. I am an advocate and engineer. I have been working for 27 years, just so we know, in Oracle. I am multi-platform, though, and multi-cloud. I work in both Google and Azure a lot, and now I'm working in AWS, so it's all over the place. But Oracle is kind of a unique platform moving over into the cloud, as is most other high I/O workloads. Oracle seems to be one of those heaviest ones, but I have moved over MySQL, SQL Server, Postgres, you name it, it has been thrown at me. And why is it kind of unique? And one of the things that we had the challenges when I started doing this, and I did it for about 5 years, running Oracle into Azure, is that, well, it was all infrastructure as a service. There was no PaaS solution at that time. We all know there are Exadatas sitting in all the clouds now. They're moving into AWS as we speak. They're already been in Azure for, gosh, a year and a half now, and they are going into Google. They are starting to move things onto Google at this point in Exadata, and that's at Exadata at Cloud, or Oracle at Cloud as they call it. There were 3 failed partnerships throughout that time where we were kind of figuring it out over at Azure, where people were like, well, maybe we can leave the Exadatas in the cloud, in the Oracle cloud, and we'll just put the applications on Azure. And we're like, not a good idea. We don't like network latency, and separating the app and the database across 2 different clouds doesn't work real well. And that was a challenge as we were working. And, this was quite a journey for us. So I think it's very interesting as you realize, what are those recommended practices when you're moving a huge Oracle environment or any huge database environment into the cloud. And most people don't really think about what is that reality of that. They kind of isolate this and think that it is one database, one application, and that's a lot to think about in itself, but it is more of an ecosystem. This is the reality of what we were seeing. It wasn't just that Oracle database, everything was connected to it. A lot of times there were multiple batch processes. There were SQL Server databases, maybe a system, a smaller Oracle database that they wanted to migrate to Postgres as part of this project. And it had to be moved over all as one, and this could become quite a monster. And you might want to integrate that into some new projects that were more greenfield, such as you wanted to bring in some new analytics, maybe some AI processes. All of this had to be part of this project that you were doing. The other challenge was licensing. There have been significant changes for Oracle as they have brought the Exadata cloud in. Be aware that there's limitations, especially around Oracle when you're bringing it into Azure, SQL Server when you're bringing it into Google, that they may say you can only have a certain max of how many CPUs you can do outside of their solution. You may only be able to have, regular single instance. You may not be able to do multi-tenant. And, multi-tenant licensing is different than multi-tenant architecture. So you may say, well, I can have 3 PDBs per CDB, and that's what I'm allowed. It is going to take more resources because, of course, more CDBs means more background memory processes than that. You're not allowed to have rack outside of that Exadata environment. Data Guard is still an option, and for somebody like myself that does a lot of migrating of Oracle environments into other clouds, I would tell you Data Guard is gold. It allows you to do fast start failover. You're able to actually give high availability in a failover environment in another data center. Rack isn't able to stretch in availability zones or data centers when we talk about that in the cloud. So that's really important. So Data Guard is gold. You still have that. That's still available to you. And advanced features that are mostly on Exadata at Azure, you're not going to have available to you. So you have to think about that and look at your actual workload and make those decisions as you go forward. So when an Exadata is migrating to the cloud, it's really important to understand that workload. We found that usually it was one or two databases that were the reason for the Exadata purchase. There were those outliers that may have said, well, it was all my databases, but didn't happen very often. We found that whale in the pond. There was that one big database that was the reason for it. And then because there were so many extra resources on the Exadata, they'd migrate everything on top of that in there. So we would take a look at it and start to identify those workloads. And the best way to do that was to actually look at what wait events were on the database, what resources, and the actual workload content of how much CPU, how much memory, how much I/O that you were actually using, and what it would require to run it inside infrastructure as a service in the cloud. And the way that this works is, of course, are they actually offloading? Most database platforms are using more of the hardware on Exadata than the engineered system features. People are kind of surprised at that. But we found this overall was the truth. You were going to find those gold mines of Oracle databases that were just built for an Exadata that are offloading. They're doing those smart scans. They are using storage indexes. They're using tons of hybrid columnar compression. This is a beautiful scenario when you see that. And I came across those and would tell the customer, this needs to stay in Exadata. But there are other ones where you would look at them and a simple index would have solved a problem. It was very much an OLTP workload. They would say, I'm using a lot of flash cache. Well, flash cache can be, available inside the cloud. You can build out your own flash cache. You're fine there. You were using rack. They may not be using it for scaling. They were using it for high availability. And you realized once you got to the cloud that rack would not sustain that high availability, and you were really looking more for a data guard solution. And once you looked at their RPO and their RTO, you realized they actually weren't using rack for that as well, or their application didn't support that automatic failover and it caused failure. All of this kind of comes into play when you're making that decision of how you're going to build this out. So as we started looking at this and started looking at licensing restrictions, you may have customers with EULAs that say, I can just migrate over anything, but they may be looking that only 80% of their license were coming over, and they were being told you're going to have double the licensing. All of this isn't that big a deal. You can actually look at these workloads and make a decision of, this one may need to stay rack, but I don't need to buy all of this autonomous DB solutions, or I don't need to invest this heavily into this. I'd like to just run this on infrastructure. And can I do it? And how would I do this without having to re-architect everything? So how we would do it is break up all of these into multiple VMs. We would find out the actual workload. We assess this very clearly. We would look at storage options, and it may not be the storage options that most people are familiar with in Azure. It's not the ones that maybe come with Microsoft, but maybe third-party solutions, not first-party, but third-party. Storage indexes, they're not replaceable, but a lot of times you found out that simple indexes might handle the workload just fine, along with additional partitioning, MVUs, things like that. And you didn't have hybrid columnar compression, but storage compression that was there could make up for some of this, where you might go from a 10-to-1 compression ratio to a 7.1, and 7-to-1 could handle it. That would give you similar performance, and sometimes even better when you got down to everything together. So how do we do this? I'm going to skip most of this, but I will let you know, just for time, At the end of these slides are links that will take you to the detailed instructions and documentation along with the worksheet to size these appropriately. And the thing is that this is what's going on. Your Oracle licensing, they would love to charge you for this. I want to make sure that you pay for what you need. Think about how you have your on-premise environments and how you size those. You have to make sure that hardware works for 3, 5, sometimes 7 years. It is on-premise, you're purchasing it, you're keeping it inside your data center. Inside the cloud, that's not how it works. You're looking for what's going to work for you for maybe the next year, next 6 months even. You could reassess this, takes 5 minutes, and up the actual VM that you're on. It is that simple. You can't do that on premises. We found that 85% of customers were over-provisioned, and by sizing them appropriately, they could actually size something that made sense and save a lot of money. I mean, a lot. So what we do is we use the automatic workload repository, which is proprietary, of course, to Oracle, does require the enterprise edition. It does require your actual tuning and diagnostic monitor with this, but that you would be able to get this. You could do this with the stats pack in standard edition too, no problem whatsoever. You can grab this data and actually size it out. Way we do this is there is a link in this slide to grab the busiest. If you're doing the busiest, do not simulate a peak on top of the peak. Be very cautious about what you're doing. We have this built in a way that you are taking a good size workload. It's usually about 3 to 4 days is what I recommend, 3 to 7 days. But remember, as you get wider, those averages come into play and will flatten the workload out. So about 3 to 4 days, you're trying to get a good meaty workload, one that covers your overnight workload. A lot of people don't realize some of their highest I/O is happening during the night. Excuse me, and my cold that I'm getting over. And you're going to grab this data, and also the space is not collected on here. So there's a second script that will grab the actual size of the database because you will need that for your storage calculations. And you're able to take this data and do a sizing assessment. Now, keep in mind, there are some bugs in 19C. We love 19C, don't we? Probably the buggiest version of Oracle since Oracle 6. Congratulations, Oracle. And then 10.203, of course, because that was the birth of AWR. There's some numbers that may be missing in there. But you can also do this for other database platforms. I'm definitely a Linux person, so you might use memstat, iostat, grab those MPAR data, grab it and calculate that information. You can do it with the performance monitor out of Windows. Look and assess your workload, and you can get these same 12 data points and provide this kind of sizing assessment. The sizing assessment you see here will work in AWS, Google. It'll work for any of these. It will tell you the amount of CPU, the amount of memory, and the amount of I/O that you need. So you're going to grab that. Yes, this report is a little overwhelming, especially for my Microsoft people. They were surprised by how much that comes out of it. But you're going to grab this data, leave what we call the fudge factors alone. Those are for, if you're doing a 3 to 5 day assessment, leave these numbers alone. This will simulate a peak in. If you're doing Exadata, of course, some of these numbers, it goes into details about this in the instructions of how to change them. If you're doing a peak, you will actually move these all pretty much to 0 outside of the CPU calculator. Things that we expect if you're doing Exadata is that, yes, we're going to throw up that SGA and PGA. We're going to want to do more in memory. One of the first things we do when we're actually migrating databases to Exadata is we shrink that all down. We force offloading. So, of course, we're going to grow it back up to do more in memory. We are also going to times the I/O by 4.0 to take care of or address that loss of hybrid columnar compression. You do have a bit of an I/O explosion once it comes off Exadata. And yes, I am migrating databases, decoupling them from Exadatas to work on standard hardware. So what does this look like? After you've put in all the calculations on the first sheet, like I said, I skipped the actual steps of showing this for time. You're going to fill out all of these databases. You're going to see this kind of data come out of here where it says this is the amount of elapsed time. This is our CPUs, our cores, our memory, percent busy CPU. We love that calculation. Very important in here. Our SGA use, PGAUs, read throughput, write throughput, read IOPS, write up IOPS. Excuse me, I'm going to tell you this very clearly. IOPS is not that important. The reason that it's not that important to us is that we care about throughput. Oracle is very efficient on IOPS, and it can be very misleading because everybody talks about IOPS when they're talking about their storage. And Oracle will be very misleading because it'll come back and say, I've got a very small number here, and then you will look at the amount of throughput required and it can't handle it. Always focus on the throughput. Megabytes per second, extremely important, more likely gigabytes per second when we talk about Oracle. And what will happen is that this data will start to calculate down, aggregate by the host, and you will be able to see what you require to run this workload. And the output of it will then come out something like this, where you will be able to see the percentage of DB time to the elapsed time, the estimated Azure VRAM. This tells you the amount of RAM that's needed. It tells you the amount of IOPS, the amount of throughput. The ones in red are the ones we're paying attention to, by the way. Amount of RAM, amount of IOPS, amount of throughput, and then the amount of vCPUs that we need. We will manually fill in the size of the database and any backup info that we need, and we have this. It calculates all of this for you in this Excel spreadsheet. This makes a huge difference. Now, a number of groups have tried to automate this. I'm betting that Google's going to do best at it. I know the team over there. I think they know what they're doing, so I'm trusting them. But this has been a cornerstone of how we've done this very well and successfully for years now. These numbers give you that capability that you know for that DB Prod 1, I'm probably going to need a VM with 40 vCPU. If you look at that right, it says 39. I'm probably going to need 40. That DB Prod 2, I'm going to look for a VM with maybe 16 vCPU and see if I can combine it with one of the other databases and consolidate. Things like that. DB Prod 3, yeah, I'm looking at that, putting that on a 32 vCPU machine. I'm going to look for one that has the amount of memory that you're seeing there. I'm worried about that DB Prod 2. It needs 96 gigs of RAM. I'm going to need that on there. And then, of course, we always worry about how much throughput that we need. Your VMs decide how much you get. And that's something to think about. As we start to assess this, this is extremely crucial as we're starting to work through this. Your VM series, there's a lot of them out there. And I'm going to talk about Azure right now, but be aware that for Google, like the C and the N series are go-tos. There are very few VMs you actually need to know about when you're assessing for database workloads. D series are pretty much your standards. Your M and your E series are your go-tos for high I/O workloads. The E series are the ones that I love. The M series are the ones when I need a lot of memory. All the rest, I can pretty much ignore. Those are for other types of workloads. And I put a link on here where you can find these out. The documentation is your friend, especially when we talk about like Azure. Azure spends a lot of time making sure the documentation is complete. Always know to look this up and look at limits and quotas. Extremely crucial if you're going to do this correctly. These VMs take the time to find out what is not just the memory and the actual RAM on it. Look at what the throughput limit is. Your VM decides how much I/O you get, not how beautiful you striped your disk, not much high I/O that you've chosen on your disk, but your VM. Your VM, and you think about this, your cloud, to be infinitely scalable, each resource has to have a throttle line. And your VM is making that decision for you. And that doesn't just go for attached disk, which is the number in the second from the right column, but the very far right column is at your network, which you need to think about too. And I'll show you why that is. They also have constrained vCPU machines. What that is where you have a bigger chassis, more memory, more CPU, but it's been more memory, but the CPU has been throttled down. So you can get higher I/O and higher memory with a lower CPU. So keep in mind of those too when you're looking for something a little different than what's out there. So as we talked about, you can scale up and down a machine very quickly. You need to change your storage. That takes a lot more time. Get your storage right before you go out the gate. Moving data files, it takes time. I mean, we all know this, especially if we're using ASM underneath the covers, automatic storage management. That takes a lot of time. We're bringing RMAN into play. We have to move a lot of data across the network. You don't want to do that. Take your time and make sure you get your storage right. That's why those calculations in that worksheet are so important. You need to make sure that is all clear. And for Oracle, we expect those numbers to be much higher. It's very normal for them to hit the limits on these. So you're going to see all of this where you're seeing premium SSD, PV2, that you have this capability to get, very low latency, high throughput. The max throughput rate is actually a lot lower than what they put in the documentation. It'll be throttled. You're going to have other things that are coming into play. UltraDisk, which everybody goes to, not actually the fastest. You're also going to find that many of these groups, the teams that build the VMs, compute versus storage, versus network storage, which is different. We'll talk about that. They're all separate. They're very isolated and siloed from each other. So as you talk to some of these teams that build out like SQL Server, high IO SQL Server, they weren't even aware of some of the network attached storage solutions that I brought to them. I had to think outside the box to bring Oracle on Azure. So I was working with Azure NetApp files. I was working with Silk. I was working with some of these Lightbits, some of these products that nobody had really heard of. And for me, I was able to get much higher IO. Now that max throughput, that's actually an old number. For Silk, I've gotten up to 30,000 megs per second. For Azure NetApp files, with AVGs, I can get up to about 15,000 megs per second. We're seeing much higher numbers than what's shown here as VMs have improved, and those throttling, of course, has gone up. So find out first what your workload needs, assess that workload, and then get the numbers that you need. And you will know what this throttling is because you're going to look at the documentation. It's going to tell you. Now, like I said, the M series is my high memory machines. Now, a lot of times when you have high memory, you may have high IO too. This machine is an older one, the standard M16MS, but it's still available. You could get it and use it. And it looks really good. It's got 16, vCPU. It's got 437 gigs of memory, but it'll throttle you at 200 megs per second. This is really, really low. And for Oracle workloads, I don't know how often I have been brought in and they're like, I striped all this UltraDisk. I should be getting like 20,000 megs per second. And you found out that the VM was throttling. The actual VM decides how much IO you get. So always take the time to read the documentation on the VM that you've chosen. Also know that there's different things like host caching and bursting. Read the documentation to find out what it is and what you can actually get for free. What you can get if you turn on different things like host level caching for these customers, you can see what you're getting for each one of these and they can say, well, I got burstable. Burstable has to be available. Host level caching is guaranteed. I turn this on and automatically get 750 megs per second. That's a little bit better than 200 and 250 megs per second if I don't turn it on. Always turn these on when these are available for you. If you need higher IO solutions, that's when you start looking at Azure NetApp files, Silk, FlashGrid, Lightbits. These solutions give you higher IO by being able to use network attached storage. Network attached storage is only limited at the NIC, at the network card, and this will throw your numbers way up. And you could also scale it across multiple VMs to get higher IO totally from all of these. This is a big deal. You can also stripe your disks, of course, going old school and getting higher performance there. These numbers can make a huge difference. And I know we've got like IOPS here. This is always the rage with storage, but always look at the megabytes per second because that can make a big difference in what you're working with and make sure it meets your numbers. Silk, that's actually a Kubernetes data pod. We're actually striping all of that. We're using VMs to get the most out of the NVMe that's on there. And you can get the scalability and the performance and connect it to multiple VMs, no matter if you're talking SQL Server or Oracle, to get that kind of high performance. I'm going to skip through these here because I want to talk about migration strategies. Oracle and Azure, one of the things that we found, and this goes for any big database, always, always, always baseline. Make sure that you know exactly what your workload is, collect all of those statistics, and ensure that by the time that you've assessed it and you start designing your system, you know exactly what you're migrating to, that you know your hardware that you're going to migrate this on can handle the workload. Very often I would hear that they were going to migrate onto a PaaS solution, and PaaS sounds great because you're going to have somebody else managing the backups, managing the database. You're not going to have to do this. And you would find out that it was a 2,000 megs per second workload, and they were going to put it on a PaaS solution that really only had 300 megs per second. If you know your workload, then, and you know that documentation, you can come back and say, this isn't going to be able to handle this, and stop a disaster from happening. You must be aware of these very large databases and what they require, and build out the solution you need. Be prepared that you may have that one whale in the pond that can't go PaaS. Move your small databases to PaaS. Your big databases, high IO workloads usually require an infrastructure as a service solution. So know that workload, perform that POC, start testing it, make sure that you know your RPO and your RTO as you actually build out your HA solution as well as your disaster recovery, and build that out, and then start to simulate those tests and verify it. Most tests that customers look at, and I know they love real application testing with Oracle called RAT, that usually becomes a project unto itself, and we've told most customers avoid it if you can. Just simulate some tests, make sure that you get the IO performance that you expect, and then move forward from there and do some real tests once you actually migrate it over, maybe with a data guard secondary that you can flip over and rebuild and start over again before you actually flip over to it permanently. Check your customer readiness, make sure your customers are on board and actually doing the testing. Nothing's worse than not having people really invested into this. And verify those recommended practices. Don't just use your recommended practices that you had on-prem. Make sure that you have recommended practices that are cloud ready. Most customers do not think about that. They lift and shift and they want it just like it was on-prem. No, bring in the cloud practices as well, so that you understand it must be a marry of both the on-premises solution and the cloud solution that's going to work across this, and have that lifecycle support that you know how you're going to fail back over if a disaster does come into play, that you have that solution running in parallel, that you can test things and look at those performance baselines, and especially if you're going to look at the AWRs and compare the two. Make sure you're identifying by the SQL ID and the actual, execution plan, the hash value, that you know those SQL statements are running just like they did on-prem. Your customers are satisfied with them. And if there's any outlier that isn't, people have signed off on it and they've said, I accept this. This is all right. We can troubleshoot, work through this, and do performance optimization over a period of time and not impact the actual project itself. As you go forward, introduce more Azure services. Find out how you can get more value out of that data. Oracle probably has more valuable data in it than any other database platform, and to be able to do that and bring it into Azure services is a real bang for the buck. And I think that's where you're going to see that no matter if you are going to Azure or Google or AWS, all of these solutions that you can see here that you can build in with your cloud services makes a huge difference for these customers. I don't know how many that have actually taken Oracle databases with Azure Data Factory, fed it into Fabric, and then started doing AI with it. This is one more way of using what may be the best solution for your Oracle data and to get more value that way. Benchmark tools. I'm going to tell you straight out, you're going to have people that will say, I love HammerDB. I've heard this in SQL Server. Not a big fan of it. Other people are. It's great for SQL Server. MySQL is not for Oracle. Slob, FIO, that's what I'm going to use for Oracle. Oracle Swing Bench, every once in a while, not very often. If you're doing Postgres, PGIO, which is the version kind of a slob for PGIO. And for you, those of you who've never heard of slob before, it's silly little Oracle benchmark. These performance benchmarks allow you to do that testing. We were talking about that RAT doesn't work really well. Slob will. Slob is awesome and allow you to actually do that testing and take a look and make sure you're getting the IO that you expect from the system, simulating workloads on the actual system that you've built without having to bring your workload over. There's one for OLTP, there's one for OLAP, there's one for a hybrid. You can take a look at it and see that it's performing the way that you want. You're getting the I/O that you expect. I/O is important. I know everybody's like, what about CPU memory? Absolutely, but I/O is really the crucial one that you see fails inside and out inside the cloud. Understand the limitations of these benchmarks, but know that they are essential. So find also like another 10 top queries that you want to test and make sure that they're performing the way that they do, both functionally, performance-wise. And then exercises, they can be a waste of time. Make sure people do not end up in analysis paralysis, as we like to refer to it, where they're just testing over and over and over again and not making a decision to move forward. Have somebody who is that decision maker that says, we've tested enough, it's time to actually go forward. And then have a very clear failback option where if they need to fall back to the older system, they can do that. And as you're looking at disaster resiliency, Azure Site Recovery is not for database workloads most of the time. They can handle, they're now up to about 100 megs per second on their throughput. But again, that's really low. We were talking about not even being able to handle 300 megs per second for an Oracle database. It is not for database workloads. People many times do not understand that. Use DataGuard. It is there for you. It is powerful. Always on availability groups for SQL Server. These are the tools that are much more capable of handling this. For Oracle, we use Golden Gate. The license is a little more expensive, but it gives you that capability of synchronizing those last few rows as you flip over. And for Oracle, they have SQL Server integration services that can do that same kind of thing. And then use your availability zones. Understand what high availability looks like in the cloud. These are data centers. Your availability zones, those are data centers. And then, of course, you've got your regions when you need to do multi-region. So when you start talking about East US, US West 2, all of these, those are your availability zones, your regions that you're going to go to, and then availability zones within there that you're going to be able to fail back and forth to. Make sure that your storage spans this. Make sure that you have backups that can handle them and cross-populate to each one of those AZs. And proximity placement groups. I'm not going to get into availability sets, but proximity placement groups are really important. These are ecosystems, as we talked about. Make sure that all of the hosts that everything is running on, no matter if it's an application, no matter if it's a database, they are connected through a proximity placement group, because if those go down and then you bring them back up, they can come up on different VMs in different parts of the actual AZ, that different parts of the data center. That distance can create performance problems, and no one will understand why. The Oracle DBA, if they're savvy, will be able to see those network latency and maybe compare them and see them in the AWR or in an ASH report, but most people will miss that. Proximity placement groups are your friend, and they will allow you to group those. You're letting Azure know this is an ecosystem, they belong together, keep them close. And we already talked about this, so I'm going to skip that. Backups. RMAN, you can use Azure Files if you want to, premium file storage to actually back up to. Works fantastic, and it works just like it did before. No difference there at all. And perform your POC, like I said, choose a valid database, application, check everything. You're doing really well on this. Go in and decide your performance. When issues arise, don't assume, gather data. Don't let people start pointing fingers at things. And then test your backups, high availability scenarios and everything as part of the POC. Don't wait till afterwards. I have seen this bring down more projects than I can count. Test, then rinse, repeat. Make sure that everything is going. And use the right tool for the job. You've already been using these tools when you're on premises. Many of these tools are available inside the cloud as well. And then to simplify it, think about the tools that you were using on-prem. There's most likely a version of that in the cloud. Consider it. Or build it out on a VM and have the same tools. If there's a way to implement a cloud solution of that same tools. So your users, your support people have the same experience that they had on-prem. Take away some of that newness, some of those challenges, that upskill that people have to do it. It will make it easier. And then maybe you can even, change things later on. Then verify and switch over. Last things, remember those lovely AWRs you took? You can use those and start to compare them and see how you did once you migrate over. Look at the performance and make sure you get something that actually has all the data in it. If there's a lot of these that are missing data in them, you're taking too small of a snapshot. It is a workload that requires a bigger window. Do that. Have numbers all across here and make sure that the performance numbers look very similar as they did when they were on-prem. So take a look at those workloads, compare them. If you get down and digging into this and you see one SQL statement or two SQL statements that are all the problem, go down and use something called the AWR SQRPT. This is a SQL ID specific AWR report. You can start identifying just separate SQL reports instead of looking at the entire AWR and start to identify what's changed. Is there a different hash value? Did it not actually perform the way that you wanted? And then maybe put in, an actual baseline to fix that SQL statement. And there we get into our SQL plan management. Absolutely consider this. Make sure that you evolve to these. This is the go-to for what customers are using for Oracle. And as I stated, find ways of bringing in new stuff. For all of our older users, Power BI is just phenomenal. You can incorporate this and use that service along with this. Bring in your greenfield projects. Look at some of your smaller schemas. Maybe you can bring them over to Postgres and even save more on your actual Oracle licensing. Data warehouse workloads, some of my customers are bringing them into Synapse. They're bringing them into Fabric. And then when we start talking about these PaaS solutions, they also are using Exadata at Azure when we talk about these workloads that are just continuing to grow, and they do need those Exadata features. And with that, I have actually gotten through all of my slides in exactly, I think, 36 minutes. So I have met mine. How was that for time, guys?
Wow.
Yeah, you did well, indeed.
Very good, very good. Yeah, thank you for the presentation. Very interesting. Do you want to start?
Let's switch over to the Q&A session. You showed us the AWR reports to identify our requirements in cases like throughput. I was curious if in my migration, there was the point where I have to choose my VM series, like the M series or C series. If I mischose the series during my migration, is there any possibility to switch it while I'm still migrating because I experience throttling, or am I trapped?
Very easy. VMs are easy to change. That's one of the nice things about them, and size off. As we're doing cost assessments in Microsoft, one of the things that I loved is that you would find out they were, and know this, all of those letters and numbers in the name of it means something. So let's say we have a DSV3 they're using. I'm going to keep it to 4 letters. I won't go to like all these long ones. And I'm going to look at that and go, a V3, that's an old machine. That's actually version 3. And I may bring them into like a DSV5. And they're going to get an automatic boost right there. They're going to get a newer chip. They're going to get better performance. They're going to get better throughput, higher I/O capabilities. Do it. It will take an outage. You will have like a 1-minute downtime. But it's worth it. Yeah, do it. I may bring them into an EDS V5 series and really bump them up and get them some better memory and everything.
Yeah, cool. Great. Thank you.
Welcome.
Then a little kind of off-topic question from the chat, whether the presentation slides will be available somewhere online. Do you publish them, or?
I do publish my slides. There is a lot of content on this out there because this is a popular topic for me. It is out there on SlideShare. I've found out that depending on how I shared them, don't go for the PDF version. Go for the PowerPoint versions because they've started adding ads to it Get the PowerPoint version. Download the PowerPoint version.
Okay.
But yes, this is all out there, as well as the links for this that will give you the GitHub access to get to the Excel spreadsheet and all the instructions.
Yeah.
Okay.
Nonetheless, the talks will be also published on YouTube if anybody wants to.
Yeah.
Perfect.
Yeah.
Yes. So all the talks you heard today will be recorded and later on uploaded on YouTube.
Mm-hmm.
So you can rewatch the session if you want. Yeah, how about if I'm not using Oracle or other database platforms? Is this limited to only Azure and Oracle, or can I apply these concepts on other database platforms too?
You
or cloud
can.
providers?
Metrics are starting to be built into Postgres, so you can grab these 12 points from Postgres as well. Perfmon with SQL Server is very easy to calculate these same values. The only thing is the percent of DB CPU you have to calculate manually, which is something that's already calculated in the AWR. But I've done it for all of those. MySQL, I can do it for. Document databases, I have not. So such as MongoDB and that, I have not done it.
Yeah, okay. Well, that could be complicated.
Yeah.
I mean, you
But then
start
you-
looking at it and you can grab, like I said, memstat, iostat, mpar. You can grab those datas from the Linux or Unix host.
Mhm.
Yeah.
Excuse me. And you can calculate that data, but it's not going to be as easy as what I already have here.
Yeah. There was an additional question in the chat about the slides. Where can they find the slides? Is it on your website or?
If you go to SlideShare under my name, Kellyn Gorman, you will see versions of these slides out there on migrating high IO workloads. Yeah. Yep.
Okay, thanks. I hope this answers the question good enough. Yeah, great. Okay. I think if there are no additional questions in the chat, then we might see you in the speakers corner. Will you join there or?
I will.
Okay,
Right, cool.
nice. So if you have additional questions, feel free to meet Kellyn in the speakers corner. And thank you for your time. Thank you for the presentation. And yeah, then we will continue on with the next presentation about platform as a product. Thank you, Kellyn.